What are we going to see today is the 2023 R1 new version of SDC Verifier, and first of all, it has fresh new look. I would say significantly updated user interface of the main window, which has a lot of which has a significant modification, and for me personally, it's much more good looking, but up to you to judge. So we'll see that. We obviously support the new versions of FEA software, so versions of 2023 for ANSYS and FEMAP. We have a possibility to detect all the structural items of your model within a single click. I just tried this feature yesterday for a couple of times, and I think this is a big changer in terms of how do you pre-process your model before the verification according to standards. We have a new code, new version of ISO 9902, version of 2020. Yet the previous version is still available, and we also published on our website an article about the changes. I think this brings a huge value. Maybe I'll show that also later. Now it is possible to filter the results in the tables. So if there is, if you have a very extensive table and you want to sort something out, or you want to search through the results table, it is much more convenient. I'm going to demonstrate that. We added a possibility to, well, this is probably the most common question when the single fillet welds are going to be available. So yes, now we have an interface for single fillet welds. It is giving a possibility to define a single fillet welds, to define the dimensions, the side of the fillet, and also preview that. We'll take a look on this. It is not yet included in the checks. Well, I'll speak about that later, but it is not yet included in predefined checks, but in the custom checks, there are new variables for the new standards. We have fixed the performance mostly for ANSYS version. There is a couple of items that are happening much faster now. I hope you'll notice that in your practice and in the future. And we also improved a couple of formulas in the standards. Everything is listed in our What's New section on our website, but I'll indicate a couple of those. And maybe most importantly for me personally, I'm also going to show you what's going to happen with SDC Verifier in the future, what is going to happen with the development of the standard version we have and the new product we are launching. So let's go through the slides just quickly, and I'll just quickly indicate every of these topics, and then I'll go to the interface. So this is how the new window of SDC Verifier is already looking. We introduced the ribbon on top. The reason for this was to reduce the amount of options and buttons that you are going to click to make the interface a bit more intuitive. Also, some of the features could be literally launched from this main window in 5 different ways. We reduced that options so you can either access most of the stuff from the tree as any engineering software, or everything is well organized and much more good looking in the ribbon on top. I'll guide you through this ribbon today and some of the new buttons that appeared there. Obviously, we support the new versions of FEA software, as I already mentioned. There is a possibility to recognize all the structural members within one click. This is really impressive and fast, and on the model with both beams and plates and welds. If you need to do all the checks, you can find them all or quickly update all the recognitions within one click. New code for ISO, and as I mentioned, I don't have the link over here, but visit the articles on our website there is a comparison of changes between ISO 2007 and 2020. The difference is not that significant, I would say. It became a bit less conservative, and there is a new check added. So it is listed in the website. Also, some of the factors are renamed, but these updates are not, well, for us personally, what we tracked, we've written in that article, and what we also noticed that it is slightly less conservative now. Possibility to filter the input, the data in tables, both by searching with a name or inputting a certain value, is also here. I'll show that to you today. Single fillet welds. So here is a possibility to define that in the weld strength settings. We will go through this interface. Some of the performance improvements and fixes. Most importantly for me is performance has been improved when opening ANSYS project that has many solutions, many loads in the model. It is faster now. So for those using SDC Verifier for ANSYS, I'm looking forward to your feedback. If you also feel that this is happening, the workflow with SDC Verifier and opening time is shorter, please let me know. I'm glad to hear that. And also performance of reading the nodal results like displacements or reaction forces is improved. So yeah, I think that's a really good news. And the full list of the new features, we're not going to have enough time to cover everything today. I'll just indicate the major things, but full list is available in standard article about, which is called What's New in SDC Verifier 2023 R1 on our website. And there you will be able to see all the fixes, all the improvements, and all the small things added. I'll indicate a couple of more, like spectral load set, for example. So yeah, maybe it's worth pointing out already. So when we're doing the combinations, we are doing linear summation of results. But for spectral fatigue, it is also necessary to do a square root of squared loads multiplied with factors. So there is a possibility to choose the type of load set right now and define either standard, as it was for last 13 years in SDC Verifier, or make a spectral load set where we have rooted results. And yeah, let's start with a sneak peek into what is going to happen in the future. We are already working on the new product in with SDC Verifier. So it's kind of blurred. It's not your eyes. It is a picture like that. And we are going to have a graphical user interface inside of this fancy new window. And we are going to have a possibility to build FEA models. Well, most importantly to import the FEA models from other CAD solutions, CAE solutions, and FEA solutions. So it will be an interface that is able to import the model from wherever else, maybe Abacus if some of you are using that, or just a step file, drawing, and so on. There will be an interface to use modeling features, so to build from scratch or to adjust the design of the model. It is going to be powered by Nastran solver. So we are going to have a possibility to solve those models directly inside of the window of SDC Verifier, and then do all the standard workflow with our program. So it will work for those who don't yet use any FEA or use multiple different FEAs and want to have the code checking in dedicated window. It is also completely it will be possible to upgrade this version to a full FEA. So it has import from any FEA solution, and it's going to have export to any FEA if you want to continue with complicated analysis in ANSYS Mechanical or FEMAP or SimCenter 3D. It will have an export. So we're basically going to call this SDC Verifier, and new and existing products will be SDC Verifier for ANSYS or SDC Verifier for FEMAP. So I expect to have a first release of this somewhere in the middle of summer. Probably our developers are not extremely happy with that, and it always takes a lot of time on adding, especially adding new products. But by the end of summer, we are going to have something public, and I believe with the release of SDC Verifier 2023 R2, we're also going to release this standalone product. So if you're using multiple FEA products and want to keep them all in one interface, it will be something where you can integrate. If you or your customers don't yet have an FEA product, it will not be mandatory, and it will be possible to import the FEA model in here, check it, and then send it. It's also nice to share with your customers. If they don't have an FEA, it will be possible to preview the results of the verification and much more. So we're coming with the graphical interface and with a powerful Nastran solver directly inside of SDC Verifier in the future. But besides that, we will keep everything updated altogether. So I'm always starting this webinars and this demonstrations saying that everything what I'm going to show today is available for both ANSYS, FEMAP, and SimCenter, and it is going to stay like that. So besides we are introducing the new product in this lineup, we will still have all the features in all the products available to both existing and new users of the software. Now let's go to the demonstration of this new interface. I'm going to demonstrate that today on FEMAP model. As already mentioned, it is completely the same for ANSYS or SimCenter or our independent product in the future. This is a very nice model because it has both different types of elements, so connections, joints, welds, plate fields, beam members. So everything is in here. It will be nice to demonstrate it, to demonstrate the recognition tool. But first of all, let's go to the interface of SDC Verifier. So this is how it is looking right now, as you've seen on your picture. The main update is obviously a ribbon on top, and now everything what was here is a bit more organized. So we have 7 different tabs of main things. I believe the file is the one that you're mostly going to use for saving and opening the project. So this is like a start tab. And also from here, you can obviously adjust all the settings and preferences of the program. And yeah, basically that's it. Home tab is the most active, I would say, because from here it will be possible to update the model from FEMAP or ANSYS. So yeah, it remains the same. If you implemented any changes, SDC Verifier will read them automatically by after clicking this update button. So if whatever has changed in your model tree, it is repeated in the same way in SDC Verifier. So if you change something, rename something, just click on this update button. Control of the views and the display button is running the analysis of the FEA. So you just click on this button and it analyzes the active job. Or at the bottom you have options, and if you have multiple of them, you can start from the list. Okay. What is also important here is that we have an access to Result Manager. We can go into the embed mode when SDC Verifier is directly embedded into FEMAP or ANSYS. I want to show this new window, so I'll stick to the standalone. In settings, there is a couple of things. First of all, most important is unit system. I hope everybody works within standard C unit system, but some of us have to deal with inches, foot, pounds, and so on. So if your model, you know that FEMA, for example, is unitless, so it depends on how do you model. If your model is built in any other unit system, you can adjust it from here. And one of the things introduced in the previous version, but I'm using that every time I'm launching SDC Verifier, maybe because I'm doing that mostly for demonstrational purposes, but this standard settings. It is a big time saver for me because here all the basic coefficients and standards and options are defined for all the standards. So if I have to define the FKM setup, I don't want every time to set the parameter. I want to define that once and then in a standard only do some fixes because most of them are usually default. So it was introduced in the previous version, but if you're not using that yet, please try because it's a big time saver in setting up the calculation, especially for standards like FKM or well, those that have multiple settings to define multiple parameters. Here is also the library, the format for legend and numbers. By the way, let's immediately adjust the numbers. By default, it's all in general numbers, but I would like, for example, to set scientific for stresses and see them in megapascals. Let's say 6 set. Yeah. Okay. And here's the library of the cross section. So that's the standard things, but in a bit more organized way. In terms of recognitions, here is all the recognition tools. I hope, well, for me, it's already the main place from where I start recognitions. It's still possible to do it from recognition tab in the tree, but this I like the most. And what I like even more is this button, recognize all, which is basically running the automatic recognition for all the structural members within your model. So that's what we're going to do now. We click on recognize all, and it starts defining all beam members, all sections, all welds, all joints and connections, beam sections, and so on. Our model is 55,000 nodes and 54,000 elements, which is relatively small, I would say, and recognizing everything within this model is taking, I think, less than a minute. Welds is probably most time consuming, but we see that it's coming to an end already. And also updating is faster. So if you already have them recognized, you can click on recognize all after remeshing or remodeling and click on recognize all to update all of them. So we have the notification in the end that recognition tool has found a certain amount of each structural members in your model. And there is a warning for the welds, because with our recognition tools, we're not only detecting the structural members, we are also checking the quality of the mesh. And if there is some mesh disconnectivity or we cannot define welded and non-welded part, it requires your attention. So if there are warnings, please check. There is probably something with your mesh. We have only one, and we will ignore that for now. Maybe we'll go to that later on. Let's finish with the interface of the tabs. On top, we have another tab with the tools. So different users use different of them in their routine, maybe rain flow counting, or the summation of weld forces, or just a thickness plot, building all the plate elements, showing all the thicknesses in the model. Basically, this is how it looks. And from here, we are able to preview them. Let's skip that for the moment. That's so all the tools that we already had in the interface, but just now all of them are grouped all together here. And the list of the standards. So all the codes are now also in here. From here, you can launch any of the standards, like a new ISO 19902, or create a custom one. So basically, everything that was already available. And after you create it, it is listed in the tree in the list of standards. So I have multiple created here for this model. And the last one is help. From here, you can reach out to our help page, which is also available if you click on F1. Don't hesitate to use that. It's pretty extensive. We are keeping this updated. And also, if you are on the main screen, you can click on F1. If you are in a specific chapter of the program, you click on F1 and you're guided to the dedicated page. So about every parameter of the program, every window, explanation to every button is available here. So don't, if you struggle with something or don't have enough understanding, especially about the standards, for example, it always has a description what are the methods used, where are the formulas taken from, what are these or that coefficients and so on. So this helps a lot. So help is available, as well as our educational materials, tutorials, YouTube channel, and so on. License manager, from where you can see who's using the licenses. Well, it's not from the license manager, it's from license information. You can see how many licenses you have available for your company, who is using that licenses at the moment, and so on. So yeah, basically this new view and new icons and ribbon on top is the biggest visual changes, but functionality wise, it's pretty much as convenient as it was, and now better with visual. So let's go to some features. So I already showed you how to recognize all the members. Our model is already analyzed, so no need to reanalyzing that. Let's go to the recognitions, and after we recognize all, we can go to Welds and actually see the full list of Welds. We worked a lot in the last year on the Weld Finder. Besides the Welds themselves, we introduced hotspot stress method, so a possibility to determine the formulas for hotspot according to IIW recommendations is available already here, and also to visualize that. The drawback of this is obviously you need to have a decent mesh size, but it is still a big automation for hotspot stress. But what I wanted to show to you today is weld strength settings and a possibility to define. So yeah, let's first check if the recognition went well. So we recognized everything. Let's select all of those members and preview them. Let's check the welds and labels of IDs, for example. Yeah, we can see here that these are the welds recognized in our model. Here we have a bit more detailed part where all the welds of this detail are defined, like this, for example, 135, which could be any type of weld, and let's assume it's a single fillet. So how do we define that this 135 is a single fillet? Let's first go to let's find that in our list. 135. So we have this weld, and now we are able to define to this weld weld type. And in the standard list, we had full penetration, partial penetration, and double fillet. Now we also have a possibility to define a single fillet weld for this part. It can be applied by sizes or by throat thickness. So you can select, I want to use a throat thickness of half a thickness of my weld part, and so on. But the hardest thing here and the hardest thing in the evaluation was actually to define where do we have our fillet, from one side or another. So there is a couple of ways of defining fillet of the weld. You can define it by weld part coordinate system, but for that you need to know the weld part coordinate system. It's possible to preview that also. You select the weld and you go to weld coordinate systems. And if I click on this, I will see the weld itself and I will see its coordinate system, which I can compare to the global one. So X is going along to the weld and Y is perpendicular in this direction. So if I now define the weld as Y positive, our single fillet is going to be visualized, is going to be calculated as from this side. If I will define Y negative, it is going to be the opposite side. But you can imagine that this is a lot of routine and a lot of manual work. So it's easier to, well, you will have probably to set this for multiple welds. So you have, well, go back, what you want to define for all of them. You can define the side of the single fillet weld by direction in the global coordinate system. So if I select the side by direction and click on this button, you will see that here you are defining the direction in global coordinate system, and it can be Y positive in global, which is negative in the, yeah, it's a bit counterintuitive, but that's how it's our weld is oriented. So we can either define in the global coordinate system, or so that is handy for multiple welds. I define all of them and say if I have a single fillet, it's always from Y positive or X or whatever. So let's keep this one specific and use 135 once again and use side Y. Well, let's do this, Y negative. So here is our Y axis. Y negative is going to be from the opposite side. Obviously, it's so after I decided from which side I have a single fillet weld, I click on apply. Okay, it is calculated. The dimensions are calculated. Throat thickness is taken as half of the thickness of the weld part. Weld type is defined as a single fillet now. But if I have in my model hundreds of them or thousands, I don't want to, well, it's hard to remember where you actually put it and how to visually check it if everything is correct. You select your weld and you go to plotting again, and here you can plot weld part throat. After I plotted this, we will have a small visualization of the actual weld in this area. So if you want to do that in your full model, I don't know, well, let's not waste time, but this is a nice way to visualize where you actually have your single fillet welds. And if I turn the thickness on, you can also see that its actual weld leg is half a thickness of this plate. So it's nice to without a need to actually model your weld, it's nice ways to visualize the way it is modeled. Big reminder here, we are still building the checks, the predefined checks. You know that the general problem of FEA analysis of single fillet welds is out of plane bending. And for the moment, we always recommended to take them as a double fillet with half a thickness, which is okay for axial, but not okay for bending. Yeah, not completely correct when you have a bending in your welded parts. So we are finalizing this and going to publish that, I believe, sooner than the next major update. So we will have a new update in a couple of months, which will have those included as well. But as for now, you are able to define not only like selecting group of your welds and setting them as double full penetration, clicking on apply, but also defining the single fillet welds of to some of your welded parts. This was probably one of the most frequent questions, so I'm happy we have an answer to that right now. And besides just the possibility to define that, you obviously want to use it in the checks. So we added a weld part and weld, if we go back to what's new, so on our website, SDC Verifier, what's new? We also added the parameters. They are unfortunately, yeah, not listed here, but weld.type and weld.side are the parameters to use in the checks for the single fillet welds. Okay, close this for the moment. Small update in the load combinations. So as I mentioned, we have always had a standard load combinations where we multiplied the load with the factor. Now for spectral fatigue, we also introduced the spectral combinations, which takes the square root of squared individual load multiplied with a factor. So if you go to load sets, and the type of them, you see by default, it's obviously always standard, but if you need to create new sets for spectral fatigue, it will be possible to define the type spectral for them. Just a small update, important for offshore wind and well, any structure where you would need to verify according to where you would need to take into account spectral load combinations of real and imaginary cases with different angles of or positions of application. And now let's go to the new standard. So if we are in the standards and we go to ISO, we have ISO 19902, which is a beam check for fixed offshore structures. Basically, parameters are all the same. The factors are included in here. It is only for tubular members. This is how the standard defines it. So there is a cross-reference with AISC, and we keep this. If you want to use AISC for non-tubular shapes, it is possible to include those. And I already noticed that Wojtek is asking about the joint checks. According to ISO, this is in progress, and in that this is a big priority for us as well. For now, we only have beams. We are now finishing VDI bolt check. Unfortunately, we couldn't finish in time to include that in this version. So we are also updating AISC 360. We are adding VDI 2230, and we are adding joint check according to ISO 19902. We will have an intermediate release with that. I believe by I'm setting the end of spring as a deadline for this. So I believe in 2 months or so, all of them are going to, well, more of them are going to be included. In here, basically, yeah, what I like the most and what I wanted to show is you can always define everything by clicking standard values once again, and please check if your yield and tensile is defined, and if it's defined, you click on yes, and you have a standard created. I already have one of them calculated, but since we have updated the recognition tools, it's going to be recalculated. But I wanted to show you, besides this, I wanted to show you filtering on the tables. So I will have to, what we're going to do now, we were going to select not all of the loads, but let's clear them and first do just the checks for, let's say, well, all the individual loads, 9 of them. Click on fill table. So SDC Verifier will start calculating this check. It is not very big and time consuming, But since we analyzed the member, it's even faster than I expected. Since we reanalyzed the members, it had to recalculate. So for the first time, it takes a bit more time for this, and later on we are able to generate these plots and tables much faster. So what we can see here is the utilization factor of the overall check for ISO 19902, and for every individual load. So gravity is causing almost nothing, but there is a big side force in y direction, from which influences significantly our model, and utilization factor is even higher than 1. That's basically the way of presenting the results and doing the checks. Quite straightforward and easy, as always. But if you have multiple of those loads, if you have multiple of conditions in here, and you need to sort out only the values you need, now in the tables it is possible to filter the values. So for example, you can select here, I want to see all the values that are only above, it's easy, but let's say 0.4. And if I click on that, I would see that everything which is above 0.4 is indicated. And at the bottom, it is an information about the filter that we are displaying only 2 out of 9 rows. Usually it's 20 of 900 or something like that in 2 columns. Also, what you can see in here, that we had one value of 0.4. So I want to say more or equal of 0.4. And click on this, and it will include also the exact value of 0.4. So this allows to display certain results, and it allows to understand your table much more. In the filter of names, there is also a checkbox of using the smart search, which was unobvious for me, so I had to ask the developers what actually is that. And this is a possibility. So by default, we are searching specifically that value that you type here. So you need to type, I don't know, if you type 5, you will filter only individual load 5. Or if you filter by top, top is in here. So that's the idea. It's like if you're typing in the value, it will find only that specific name. If you use smart search, it will use everything, including top. So if you have something written top side or whatever, it will also find the others with that specific group of characters. And in the end, of course, it is possible to export the table into Excel, for example. And what I wanted to show here, it is nice to see that it's possible either to export the data filtered or full. So I can imagine specific scenarios where you only want to export filtered. So for example, you click yes, and SDC Verifier exports into Excel the filtered data of the table. If you select no, it will be all of them will be exported. And now we have this list. So we see when these results were generated and what results you wanted to present. That is basically all of the most significant or most visually visible changes in SDC Verifier 2023 R1. I already answered one of the questions about the ISO code, but maybe there are other questions. I see there are other questions in the chat. Petro, can you read them out loud to me?
Yeah, one moment. Yeah, there were questions about ISO and join check, and also there are questions about recognition tools. That in that tab there are some BIM section to recognize tools. What is this? what do that tools do? Yeah.
Yeah, so besides the beams, joints, and so on, we have a beam section recognition, which basically detects the groups of beam members laying within a certain direction or coordinate. So in our model here, we have, let's say in Y direction, we have a frame of elements, or in X direction laying within the same coordinate. So if I select Y 1.8 and click on preview, SDC Verifier will highlight what it defined. It is convenient for big lattice structures where you need to report the results. You can report them by section, that frame 1, frame 2, or section 1, section 2, section 3. So it's basically beam members grouped into global planes or custom planes for ease of reporting and result presentation. Thanks. Any more questions?
I don't see it in a chat box, but maybe someone wants to.
I see something was, I'll stop. Unfortunately, I cannot see these questions when I am sharing the screen, but I can stop
I
sharing.
saw one new question in the Q&A section. We are using FIMA 2022-21. Will be there a problem of output vector numbering if we use SDC Verifier 2023?
Output vector numbering. This, I know, this is an update in FEMAP where there was a notification of output vector numbering. You had to ignore it for once, and it is never shown before again. Yeah, this is a very specific questions. I need to check with the developers, but I think it was fixed immediately in the next version, and this output vector numbering is never appearing anymore. But I will check it with developers and reply to you again with an email. Thanks for the question. I'm 90% sure it's fixed and it's never appearing anymore. It was only in 2021 version, but I'll make sure and send it to you with an email. And I also see another question about the error in the Eurocode 3 check I-beam to RHS connection brace. Yes, it was already corrected. So in the list of corrections, CHS, not sure, fix the formula of parameter, fix the parameter of CHS. Yeah, so the fixes are written here. About the I-beam, need to check what exactly, I think maybe it is this one. I will also take a look with the developers if it's not listed here, but yeah, it should be checked already. I'm not sure about this specific error, Wojtek, but I will talk to Bogdan and let you know. It should be fixed already. Okay, and I was expecting that I'm still sharing my screen, but I am not. Okay, well, at this point, I would like to thank you for joining this session. It is a lot of people here, a lot of new people. Thanks for your time today. Thank you for using SDC Verifier or your interest in SDC Verifier. You are always welcome. I'm always open and available for conversation. Send me a message at oleg@sdcverifier.com, or well, it's not hard to find my number, so call me if you have any struggles. I'm happy to hear from you again soon, and please go to our website and download new SDC Verifier right now. Let's work with the most up-to-date version and most good-looking one. Thanks a lot, and yeah.
Also, we will send you the recording of this webinar, maybe tomorrow or on Friday.
Okay.
We will do it as soon as possible.
Okay, awesome. Thank you very much. Have a great day ahead, and see you soon, I hope. Bye-bye.
Bye, thank you.